Hi, everyone. My name is Monica. I'm civil engineer. I worked for Embraer doing some planes. I'm a little bit rusty to make presentation in English, but I'll try to do my best, okay? I'm going to share with you a PowerPoint, okay? Well, my work is about a space habitat. This is my work for my PhD degree. I'm master in build information modeling, and my PhD is about space habitat using BIM, build information modeling, and building energy modeling. Well, some weeks ago, we've got 8 billion people in the world. And with this, we have some issues to discuss. For example, the land use, the water use, the environment, especially here in Brazil, we have a problem, a serious problem with Amazon. The habitability, most of the people do not have home, especially in underdevelopment countries, and sanitation, even in big countries, we still have problems with sanitation, and the pollution each time is increasing. Well, climate change is one of the worst things we're living now. And we're fighting, all the countries are fighting for stopping the increase of temperature and climate change and heat radiation. So we can modify those circumstances that you can see in this infographics. Our soil is with layers, each time smaller layers, and ice is melting. All of this because of greenhouse effect. And because of some gases that provoke this increase of greenhouse effects. Of course, heat radiation is one of the top issues to think about. So, talking about smart buildings, I think a space habitat can be similar to smart buildings, where we have automation and technologies, just like sensor, consumption, clean energy, green building certification, water and energy efficiency use, ecological materials, and performance analysis. All these issues can be managed with IoT technology, Internet of Things, for smart buildings, increasing the security, the lighting, the HVAC, fire safety, and monitoring 7/24 issues and systems, and etc. Energy management also, where we here in Brazil, we're having new buildings with energy farms, photovoltaic and aeolic energy farms. And this is not only in buildings, but it's spreading in smart cities. These smart cities can involve all issues that provoke the climate change and the increasing temperature in order to management and control the spread of buildings in an area of the city. Building information modeling, which I took my master in this area, in this discipline, is a concept of a process of design a building. In this model, we have a 3D model in the internet that can be accessed by all people related to the construction. Since the conception, the briefing with the architect, the stakeholders, and the constructors and engineers, etc., we can put in only one model the structure, the systems design, the industrialization of equipment, materials, and we have also the planning during all the time of construction, and after the construction, the operation and management, the costs, the logistics of the building area, and those things are during the life cycle of the building. Doesn't matter if it's going to be demolished or if it's going to be retrofitting, but this database must survive the existence of the building. Another discussion is about what is building information modeling. Well, Chuck Eastman described BIM as a process supported by several tools, technologies, and contracts that involve the generation and management of digital representations of the physical and functional characteristics of places. This is the best description of BIM. And BIM can have many dimensions, not only the project, the 3D project, but the planning, the costs, the sustainability equation, the management of the systems, the insurance and the security of people inside the building, lean construction, which optimizes the construction, and the industrialization of materials and issues during the construction. Besides BIM, we have BAM. BAM is the building energy modeling. It's an analysis of the building related to its location, its position, its orientation, the envelope, the material which is closes the building, internal gains in terms of energy, in terms of water, in terms of issues inside the building, systems and outdoor air ventilation, energy generation. Most of them can have an aeolic turbine or a photovoltaic and operation profiles also can be seen in them. This is an example of an aerospace hub, which is it's been planned in Japan to use as a hub for space shuttles, but also space fashion shows, international conferences, majority of space-related events, research, business, etc. It's very beautiful, and it's made with BIM, with BAM. Those are the shuttle fingers. It's very beautiful. And this is an uptouch. Some people won this prize, NASA prize, with Mars June Alpha Icon, and its process of construction, which is 3D printing, a big 3D printing. Here we can see the model, the walls, the mass that the 3D printing can create the walls. And here are the walls inside the 3D printer. Aerospace use also BIM and BAM technology. That's why my PhD is about this in this area, aerospace. Well, we've got the first plane, Santos Dumont with 14 bis. We've got Yuri Gagarin, the first man to see the Earth outside. We've got the Neil Armstrong, the first man to land the moon. But now we're having journeys, voyages to outside the Earth. We can see Bezos with his Origin, the Virgin, and some probes in other planets, for example, in Mars. So in the future, quite close, we will have hotels in other places outside the Earth. So we must think about how to do it. Well, developing habitats, we have to study the place, the conditions, the atmosphere, the temperatures, solve all the equations, and start the conception with customizing softwares, technologies, smart materials, methods of construction. We have disciplines with BIM, with BAM, and after all, we're going to have the virtual design construction, the same that we have today to build a building. Here are some softwares involved in BIM, some softwares that can be used based on industry foundation classes, energy parameters, and modeling since the start to the end. Well, my vision is the same that Buckminster Fuller always have had. He made the Parc Jean de Parot, St. Helens Island, the Biosphere in Montreal, Canada, which is very nice, and it's similar to our habitat. Our habitat is also with a geodesic, a half of a sphere with a glass cover and a protection, retractile protection over the cover due to storms and meteor showers that can be happening. Our habitat has lots of greens, plants, and there is a construction, a building of 2 floors, one way, flowers. We have a green garden. Here we have the vehicle to exploring outside. Here is the building with 2 floors and terrace over the top floor. Downstairs is a living space and systems. And upstairs we have the workspace with labs and computers and everything. Here you can see a view. The elevation. The cross-section showing the stairs and the top floor with the computers and the lab. Here we have the vehicle. The green garden is here. And we have an entrance tunnel providing protection to the atmosphere, inside atmosphere. It's a geodesic with protective cover. This is the cover that opens and closes. You can see the model. We're doing a fly-through inside the model where we can see the vehicle, we can see the building, we can see the green garden. The protection. This is the protection for the green garden. And we can come inside. Entering, we have the hall with the stairs, the living space. This is not detailed yet. This is the first fly-through that we made. And the second floor, where we have our systems control, our labs, our development, research, and everything. Well, here is the habitat outside with the lights inside. The entrance and the vehicles. Okay, this is the exploring vehicle. This is the green garden, the building. This is the gym area, a part of the gym area. This is the other part, because it's essential for humans to do exercise outside the earth because of the bones and the muscles. This is the top floor and the green garden shown from above, from the cover, the geodesic. The hall with the stairs. This is the living space. Here is the kitchen and the eating area, the dining room. Here we have the private area. This is the living area where we have cinema. That we have to have this because sometimes we have 4 people during 1,100 days outside the Earth. So they can live, and we have to care with the brain and the feelings, the psychological status of people who lives there. And here is the mission control. This is the room that we can switch on, switch off all the systems. In the private area, we have water closed showers. We have the dorms. The dorms are private. So we have, in one side, the bed is down. The other side, the bed is up, but one can't see the other. This is the view. Well, construction methodology, how to build it. The construction methodology is a process to use the construction that encompasses the type of material, process, logistics, optimization of all available resources in the stage of the project. Remember the 3D printing. We have to use, adopt the idea of green certification to do the right way, the new buildings outside the Earth. And one of the reasons is to reduce contribution to global climate change, not here, but there also, improving individual human health. That's very important outside the Earth. Protect and restore water sources, protect and enhance biodiversity and ecosystems, promote sustainability, sustainable and regenerative material cycles, improve quality of life in the community, here, there, anywhere. By the way, you start thinking of an habitat, you have to think about the same things, the same issues that you use to construct on Earth. Well, materials degree aggressiveness is very, very important. The life cycle of a product causes impact on the environment, ranging from extracting the raw materials and the completion of the production process, as well as its work throughout its life until its demolition. The same as in Earth. This is the International Space Station, which has the similar systems used here to construct a building. We have also the virtual design construction by calling in your tablet or in your smart cell a system in the real location. You can see all the documentation related to that system in your palm. And consistence of a life on Earth, we have the life support system, the living environment, the atmosphere, the climate, conditions, and aggressiveness. Other aspects to consider also when you construct an habitat outside or off Earth. Well, this is a suggestion of an habitat, but we are here to listen to all of you with a contribution that all of you can bring for us, can bring to our community to discuss the future of an habitat outside Earth or outside or inside Mars, inside the moon. Well, what will it be like to live in an habitat? That's the question we're going to try to understand and to answer in the future, in the near future. It was a pleasure to be here. Thank you very much for your attention and interest. Thank you, Professor Julio. I'm very pleased to be here. It's an honor. And goodbye, everyone. Till next time, okay?